Hello everyone. In this video, we will solve this first order differential equation. We are going to use algebra to separate the variables. So that's the method that we are going to use. And in the end, we are going to express a general solution of this first order differential equation explicitly for y. Alright, so in here, I would like everyone to analyze this equation for a few moments. Then from there, we will decide what step we are going to take. Okay, so separation of variables means that whenever you have a term involving y, then it should go with dy. A term involving x, then it should multiply with the dx. Okay, so 2 times dy is okay on its own. You don't have to worry about this because the integral of 2 dy will be just 2y. But if you take the integral of this, you will have the argument having the y square in here. Here's dx go with the ln of x cubed, so it's fine. But there's somehow you have a y square involved as the argument of ln. So whenever you have something like this, the only way you can do is to work with the property of natural logarithm. Okay? Now, on this side of the equation, if you multiply dx here, you will have 7x squared times dx. If you integrate that, you are fine because you have 7x squared and then you multiply by the dx. But you multiply dx into this bracket, you see y of ln of y squared dx. There's no way that you can separate the variable because though your y here, your y square is the argument of ln. And how do we get rid of a y square as the argument of a ln? Unless you divide it by ln of y square. You divide ln of y square, you divide ln of y square. But you may be able to do something with this, but then you divide by ln of y square. But is there an integral for something 1 over ln? Okay, you may not be able to use any formula for that. So we have to go back to the concept where I would like you to move this entire term over to the side of the equation, factor out the dx, okay, and then somehow you can work with all the term involving the ln inside this bracket with this ln so that you can apply the property of natural logarithm before you can separate the variables. Okay, so before we can separate the variable, we still have to have quite a few algebra to think about what step we are going to approach. And in this case, I really want everyone to think of moving this one over to this side, factor out the dx, apply property of natural logarithm to get rid of the y square. Okay, so let's get started. I will rewrite 2 dy equal to 7x squared plus ln of y squared dx. And then I subtract that with natural logarithm of x to the exponent 3 y squared dx. So I am going to factor out the dx. Excuse me. Okay, factor out the dx. So when I factor out the dx, I am going to take a look at these two terms. Alright, I'm going to apply the property of logarithm. So property of logarithm saying that this is in fact equal to ln of m divided by n. So this should be an n here. Alright. Okay, so I will apply this property of logarithm. Then I have 2 dy equal to 7x squared plus ln of y squared divided by x to the 3y squared. Alright, so this is quite logic because I have that divided, so my m in this case is y squared. Okay, and you will involve this entire thing as your n. So that is m divided by n. Having done that, I can immediately cancel out the y squared as the argument for the ln. Now I end up with this. Okay, at the same time, I'm going to bring x cubed up and make that into the x to the exponent minus 3. Okay, so before I do anything else, I'm going to apply another natural logarithm. Okay, so this one I apply the formula as ln of n raised to the exponent p. I can take the p, multiply by the entire natural logarithm expression. Okay, so if you have the ln and its argument raised to a power, you can take that power and multiply and make that into a coefficient. It's part of the property of logarithm. Okay, so now I can do this. You are going to multiply dx in here. Okay, you're going to take dx, you multiply by each term inside the bracket. At the same time, you will take the integral for each term. Taking the integral for each term, this one I will have 2y. Alright, so I'm going to add c1 here. This will be 7 over 3 x to the exponent 3 plus c2. And don't forget this one is minus 3. And then I will multiply that with x, and then will be ln x minus 1 plus c3. And the formulas for this would be integral of ln of u du will be equal to u times ln u minus 1, okay, plus c. Right? So that's the formula that I'm going to use for this. So instead of just u, it's just x. So here's 3 times x, ln x minus 1 plus c3. And they asked me to solve for this differential equation, but in the general solution, I must express everything explicitly for y. Okay, so let's do this first. 2y equal to 7 over 3x cubed, subtract 3x times ln x minus 1, and then I can just add that with the c. Okay, so now I have to divide everything by 2. So this will be 7 over 6 x to the exponent 3 minus, okay, so if you want to multiply this inside the bracket, you can. 3x ln x. This one should be divided by 2. And this multiply should give me 3x, and this should be divided by 2, plus c divided by 2. Alright, so that should be my final answer. 7 over 6 x to the 3 minus 3x times ln of x divided by 2, 3x divided by 2, c divided by 2. So I just want to write this again as x to make sure. Okay, so let's continue to the next question. I have one more question here, and solve for this general solution for differential equation using algebra to separate the variables and express the general solution explicitly for c in this case. Alright, so now you see that you have this one as dy multiplied by this e to the exponent x to the exponent 3, and dx, there's a y involved. So this is simple for you to separate, okay, because it doesn't involve the ln. But in this case, I recommend that you divide by x to the exponent 3 as the exponent for e, okay, and also at the same time divided by this statement as well, the one inside the bracket. Okay, so let's try that. I will have e raised to the exponent x to the exponent 3 dy. I said that we divided by e raised to the x to the exponent 3, right? And then here the same thing. Okay, I divided by e x to the exponent 3. I also divided by cube root of 1 minus 5y. Cube root of 1 minus 5y. Okay, so doing this, I know that I will have that cancel with that, and that cancel with that. So when that cancel with that, what do I get? I get this as dy divided by cube root. I may as well convert this into exponent because I know that I'm going to multiply, right? I'm going to integrate, I'm sorry. And okay, I will do it step by step. I do step by step. So 1 minus 5y, all of it raised to exponent 1/3. And this one I will write x squared dx, okay, e x to the 3. Alright, so now, in order for me to integrate, okay, so integrate this and integrate this, because I have dx as the differential factor of all of this involving x, dy as the differential factor of all of this involving y. So in order for me to integrate this, I need to convert this into the exponent of 1 minus 5y. All of this raised to exponent negative 1/3 times dy. Okay, for this, I will write it as e to the negative x of exponent 3 and x squared dx is also an integral as well. Okay, so now they all, in order for you to integrate this and this, you must use the substitution method. Okay, so here I will let u equal to 1 minus 5y. So du over dx equal to minus 5. Okay, agree? Because the derivative of 1 is equal to 0. Derivative of negative 5y should be equal to negative 5. So I should have dy over du, du over dy. So over here, I should get back to, so du over dy will be equal to minus 5. Okay, then I should have du divided by minus 5 equal to dy. So I'm working with dy, so I should remember it is a dy. Okay, so we complete with this. And here I'm going to let u equal to, whenever you work with e to the exponent, that means you should let that exponent of e equal to u. So let u equal to minus x to the exponent 3. So du now over dx, it will be equal to negative 3 of x squared. Okay, so I will have du divided by negative 3 equal to x squared times dx. So here's my x squared times dx. It's matching. Alright. So everyone got that? Now we are going to move to the next page so that we can substitute our u in. So what I have next is the integral of u raised to the exponent negative 1/3, and instead of writing the dy, I will write it as du divided by negative 5. Okay, see here, dy divided by negative 5. This will be the integral of e to the exponent u, because I let the exponent of e equal to u, And instead of writing x squared dx, I will write du divided by minus 3. Alright, now I'm going to simplify my integral before I integrate. So minus 1/5 u to the negative 1/3 du. Okay, negative 1/3 e to the exponent u times du. So this should be an integral sign. Alright, so now negative 1/5 and negative 1/3 plus 1. Negative 1/3 plus 1. So negative 1/3 plus 1, what do we get? We should have negative 1/3 plus 3 over 3. So it should be 2 over 3. Okay, 2 over 3. So I'm going to write u to the exponent 2 over 3. Here I multiply by 3 over 2. This should be plus C1. This is equal to negative 1/3 of e to the exponent u is the exact e to the exponent u again. So this one plus C2. So now I'm going to simplify and substitute in the variable. So in here I should have negative 3 over 10 multiplied by, I let u equal to 1 minus 5y. So that will be 2/3, negative 1/3. And then this one is e to the negative of x to the exponent 3. And on this side, I will let it equal to c. But the question asked me to express my equation explicitly for c. So I'm going to move this over to the side of the equation. 1 minus 5y. All of it raised to the exponent 2/3. Plus 1 over 3 e raised to the exponent negative of x to the exponent 3 plus equal to plus c. Okay, so in this case it's equal to c. So you have to express something as positive exponent. Then this should be 1 over 3 e x to the exponent 3 equal to c as the final answer. Negative 3 over 10, 1 minus 5 times y, all of it raised to exponent 2 over 3, 2/3 plus 1 over 3, x to the exponent 3 equal to c. Alright. Okay, so this one is pretty simple. Pretty simple in the way that you can divide. Okay, divide to get rid of the variable that you don't want, so that you can separate the variable, the one involving the y with the y, so you can integrate the one involving x with the x, so that you can integrate. So after you separate the variable, you'll be able to integrate like this using substitution method. Okay, so I kind of did it very slow, step by step. Okay, so thank you everyone.